Hello, everyone, and welcome to this community meetup. I am Ryan Mockey, a developer evangelist here in Mendix community team. Our regular host, Jan de Vries, isn't currently here. He's on vacation in Italy. So he's asked me to step in just for today. So today I'm joined by Jeroen Appel and Lennert from Clever, and Jon Higginbotham from Exp Realty. And they're going to be talking about data consistency at scale and how to achieve this how they achieve this at Exp Realty. So as always, you can ask your questions in the chat. We will get to them at the end of the session if there's time. That's all from me for now, but one last thing before I go, and that's if you haven't registered for Mendix World, make sure to do so. I'll put the link in the chat. That's all from me. So over to you, Jeroen.
All right. So yeah, welcome everyone. So thanks for the introduction, of course. I think that's a good thing. So I will just move a few things around here. So my name is Jeroen Appel, and welcome to the first official Clever Mendex meetup. So today we will dive into the complexity of distributed systems and discuss how we can keep your data consistent at scale. So this session will be co-hosted with Exp Realty, and we are very happy that Jon is able to join us today. We will come to the introductions right away after the agenda. So again, if you have any questions, you can leave them in the Q&A section as well. And I expect them to answer them at the very end of the session. So we have had all three of them. So as you can see here, our agenda, we're fully packed with 3 sessions in a row. So after the introduction, I will provide you a crash course. So it's mainly on how to cope with exception handling in a multi-app landscape. I expect it to be most interesting for junior and media consultants or concerned product owners. And afterwards, we will receive the main course with Jon and Lennert, and they will explain how Exp Realty is using Apache Kafka to scale their microservice architecture. Jon will guide us through the company and the architecture itself, where Lennert will teach us how to implement Kafka in your Mendex environment. So let's go to the introductions right away. Jon, I think it's awesome that you're able to join us today. I think that's a big plus for online meetups instead of physical ones. Would you like to introduce yourself?
Sure. Yeah, my name is Jon Higginbotham. I've been with EXP for about 1.5 years. And I've been a Mendix developer for about 6 years now. And I actually joined EXP, I think, when I saw their one of the original presentations that they did at Mendix World a couple of years ago about microservices. And from there, I was interested and joined the company after that.
Oh, good story. Thanks. Then I think we can give the mic to Lennert. There he is.
Sure. Hi. So my name is Lennert. I've joined Clever about 1.5 years ago, and that's also when I started with Mendix. And I've been with EXP for, I don't know, 9 months or so. So yeah, that's me.
Very well. And then myself, I am with Clever, working as a Mendex consultant as well for around 5 years now. I'm also a machine learning enthusiast and meetup leader at Clever. When I'm not working, you will probably see me doing scouting work or brewing my own beer. And otherwise, I am enjoying my time outside with my girlfriend and doing stuff like that. So I think it's enough of us, and let's dive into the material itself. I will go to the next slide. So there it is. So the first session, we tried to create a meetup where there's something to learn, or at least refresh for all levels of Mendex makers, but also for decision makers product owners. For everyone, there should be valuable insights. So first of all, the crash course with about challenges with distributed systems, and that would be me. So as a Mendex developer, I think we've all been there, integrating with systems to handle data or trigger actions. And of course, by using the Mendex platform, this has become easier than ever. But nevertheless, it can be hard to cope with complex systems where the other party might become unavailable or unpredictable. So in some scenarios, we are the ones who control either one or both of those parties. So this will be like 15 minutes of your lives, hearing me complain about how complex stuff has become, and we all gonna cry collectively. No, that's to be serious. I think I pinpoint some points of attention related to distributed architectures and provide some advices on how to handle exceptions in those scenarios. So hopefully this session will create awareness, or as a mentor once told me, trigger a wet socks feeling. And I'm not sure if that's a thing in English, but I think you get the point. So let's try our best and keep this under 15 minutes. Let's say that there are three types of main types of distributed systems. Then we have first the offline systems. Then you can think about batch processing or data analysis. So there are fewer use cases, but it's the most robust option. It's scalable, self-sustainable, fewer complex and critical fault scenarios as it is somewhere else doing its job irregularly. Then we have the soft real-time systems. Those are more critical compared to the offline scenarios and further connected to ongoing processes. So they're like acting from the sideline, so with more time available for performing its tasks. And then you can think about a search indexer, for example. So if the update process for that search index fails, then the previous index is still there, and the results will be up to date at the next interval. So you can think about a soft real-time system like that. And then we have the hard real-time distributed systems, and those are the hardest to manage. You can think about the request reply systems, transactional systems. Speed is always important because of waiting customers or running processes. And I think this is also the one we see most often when developing our apps. So let's suggest a scenario just to make stuff a bit more visual. So we are using Mendex as an order management system. And at a certain moment in time, an employee tries to update the status of an order. Nothing special. But out of nothing, the system becomes very slow. And it stops responding eventually. Because on that exact same moment, a scheduled event has caused the application to run out of memory. So the application logs are showing that the app will be rebooted, everything is broken. And although the employee did not cause the issue, both processes share the same tables, the same system, etc. So thereby they shared faith. And you immediately know that things are going wrong and you need to re-add or at least check that order if it's there. And this single application setup rapidly becomes more complex when the out of memory issue, for example, was caused by an external request. So think about an external website or web portal which is sending new orders to that same application. And now, because there is a bug in that website, the updates are overwhelming the order management system. So the website will still be available, but random things will start to fill. And the employee might report the issue and your monitoring solution will report an alert. But how to cope with the processes in their consumer-faced web application? The consumer application should be able to handle like a number of scenarios. And for example, has the create order request been delivered successfully? That's something you can think about. And if so, did the order management system process that request? And maybe the order has been processed, but delivering the response to the consumer app failed. And what if everything went right so far, but the consumer app is unable to update that status when receiving the response? So as you can see, it can be hard to handle all these scenarios in both systems. And altogether, you can see that the complexity increases at a high pace. So you will need to handle all that potential errors one by one. And testing this kind of architecture will be just as hard. So even within the consumer application itself, you might come up with a large number of test scenarios already. So when testing this in a distributed setup, the number of cases will grow exponentially, especially because of the variety in network and processing issues that might occur. And what will you do when an unknown error occurs? Has the order been processed by the management system, order management system at all? And there are a few other things which make this quite hard, and that's bugs. So especially when you're talking about distributed bugs, they can be hidden for years. But they can have a large impact on your production environment. So most often a very specific combination. So you can see that like the perfect storm could trigger a number of failures in an environment where it's hard to pinpoint the exact cause of those issues. So I think we have a few options to choose from when thinking about handling this kind of failure. And there are 4 categories for now. And in this session, we will see why one of them isn't the preferred option. And hopefully that will be the takeaway of today. So in short, there are 4 categories. There are retry, parallel attempts, failover, fallback, and where the first 3 of them can make your application more robust, the last one can cause more issues than it's trying to solve. So let's review them all. First of all, there's retry. This will be my personal favorite, especially when implemented correctly. There is an awesome web flight module available in the Mendex marketplace. It's the queue module. And possibly starting from Mendex 9, you can replace that by using the task queue. But that will be in the future, as it's not supporting retry at the moment, as I've seen before. Then the next one will be the parallel attempts. I think this one you don't see that often in Mendex applications, at least not for me. And it's also requiring a different kind of design where at least once delivery is accepted. So therefore, it's not often used, but you just send the same request a few times and you expect that one of them will be processed properly, in short. Then we have failover. That's exactly the same message. You send that to another endpoint. So you're expecting the same behavior, but for example, China is down, so you will send it to Europe, or vice versa. That could be your failover. And then there is fallback. And when talking about fallback, you do something else compared to what you originally wanted, but you are trying to reach the same goal. So that's the last one. And now we will jump into a scenario again, because visual stuff works better. So you build a solution in which you need to send a file document from system A to system B. So you are the developer of system A and deliver the solution in which you are using the web service of system B to send those file documents whenever the processes requires it. So not sure about the process which is requiring this, but you get the point. But unfortunately, system B is not always available. And in addition to that, system B is not able to cope with larger files at an irregular interval. So as the business reported that critical documents are now missing, you implemented a fallback scenario. Whenever system B throws an error of any kind, you send the documents via mail to the relevant business unit. And now they can use the documents directly and upload them to system B themselves. So in reality, this will look something like this. So very schematical, but then you see some Mendex to that, so that's a good thing. So this might seem innocent, and yes, I have seen comparable solutions like this in existing applications. The rare case will be handled by the employee as soon as he or she opens the email client, and the 1 or 2 day delay has somewhat be accepted by the business or even asked for by the business because they said this was a good idea. So although this might feel as a decent solution, which will be accepted or even asked for by the business, there are several reasons to not go with this option. And in addition to the possible compliancy objections, so who can access that mailbox? Are there valuable documents going back and forth to people who are not allowed to see that? There are also a number of technical considerations. So potentially this fallback isn't worth it. So you're trying to reach the same goal, but with a trade-off. And is this trade-off worth it? So with this scenario in mind, you're introducing an alternative process. We saw that, like the employees uploading the documents themselves. So this is a manual action. So imagine that the company now will grow over time. And over the years, a major outage of system B is causing the business unit have flooded mailboxes with too many manual steps to go with the extra work, because they didn't think that through that would happen in like 3 years or 4 years. So this situation tells us that most often it's not worth the risk implementing a failover like a fallback like this. So the impact of the fallback scenario, so the potential need to upload hundreds of documents, can be larger compared to the initial failure. And then a fallback scenario is likely to be triggered rarely or not at all. So because of this, the impact of your fallback logic is often underestimated. That's just a developer thing. They think this might happen, click, 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 and there it is. That could be something that's happening to you as well. So think about that mail scenario again. Because of the implemented solution, you might expect that the document will always be there because you have something, you have built something, so you expect the document always be there. But what if your fallback mechanism is also failing? So the mail server could be unavailable, or what if the fallback is so rare that in a few years that mailbox doesn't even exist anymore where you was supposed to send that document to. So the fallback mechanism itself can create an unpredictable load on your systems. And again, then it's causing more pain than initially. Then we have testing. So testing a fallback scenario is also quite hard because you need to force your entire system into a state where that fallback mechanism will be triggered, and that can be hard. So because it's less likely to be triggered, it might be considered as a harmless piece of logic in your application. And the nature of such solutions increases the likelihood for hidden bugs that might be hidden for years and years. So when multiple fallback scenarios in a distributed fashion, so you have quite a lot of systems, then it's even harder to create that perfect storm on your own and to see if you have pressure points in your landscape. So I found this quote when reading through AWS blogs. I think they are also very helpful for us as Mendex developers or just as consultants in general. There are very interesting things about architecture there as well. And don't be sad. We will quickly go through some ideas on how to handle this better. So after hearing about those potential pitfalls, you might be looking for those potential alternatives. So many presentations alone can be spent on this, but hopefully this section will give you a head start. So first of all, you can design and build more resilient and durable non-fallback scenario. So you can decide on using only services with a high availability. That could be one of the things. Then make the source application responsible for handling the error. Keep things manageable and as expected. Then again, my personal favorite, so the retry mechanism, if possible. Most often, very small things go wrong when interacting between systems. So just a small networking hiccup or a small this. And the retry mechanism with an exponential backoff can make your architecture more resilient. You can also create a failover instead of the fallback. Then, of course, you need to make sure that the output of that failover process is just as reliable, and the output is exactly the same. And you need to test that failover. So by using both options in your production environment on a regular basis, so you don't have surprises in a few years. And then the last one is proactively push data, because pushing your data to other listening parties as soon as it's available makes that it's available as soon as it's required. And thereby you become less dependent on those other systems to be available because the data is already there. Of course, you can combine this with decent retry logic. And decoupling your applications and choosing for an event-driven architecture will solve some of these challenges by design. So hopefully you can keep this in mind while watching the rest of the session, because I think some of these things will come up later as well. So conclude. Focus on the logical paths in your logic that occur regularly instead of rarely. I think that's an important thing to start with. Strive to make your main systems more robust and more predictable. Use push instead of pull whenever you can. And if fallback logic is really a necessity, make sure that it's testable and guarantee that the alternative is just as stable and just as reliable as the regular flow. So if there is already one outage prevented by informed architectural design decision, then this session was worth it for me. That was the crash course. Let's see. Yeah, it was like 15 minutes, maybe 16. So I'm happy with that. I would like to suggest to give the floor immediately to Jon and Lennert to go on with the main course of tonight. And if there are any questions at the end of the session, we will be happy to answer them. So thanks for now. And Jon, it's up to you.
Thank you. Here, let me share my screen. Could you end your screen share so I could share? There we go. Oops. Okay, so again, my name's Jon. I'm with EXP, and I'll be talking a little bit about who EXP is. You may have heard our story before, and how we're using microservices, and then I'll segue into the communication piece for microservices that we use for the most part, which is Kafka, and Lennert will get into the nuts and bolts of that. But first, I'll start with who is EXP Realty. If you haven't heard of us before, we're a real estate brokerage. We're based here in the US, but we operate worldwide. I think we're in something like 14 countries now. Like, it seems to grow by the day. We're completely online. We were like that before COVID, which just means we don't have any traditionally brick and mortar offices. We all work from home. And we have roughly 50,000 real estate agents. And so what does that mean really for me, my job being a developer and on the technology side? That means that we have to support those 50,000 agents in what they do. Mainly, that means creating and managing applications that support all areas of the business, which include onboarding agents into the company. It includes processing those transactions that those agents process. So what those transactions are is an agent, a real estate agent, as you might think of them, would either buy or sell a house or help people do that. And that constitutes, and there's a transaction. And with that, there's a lot of money that needs to be paid out, some regulatory things. So we need to have our systems that support that. And then there's so those two things are really the biggest lift that our systems provide. But of course, there's a lot of other things that we support those agents for. That could be with helping with sales or anything around what a real estate agent might need. And the biggest thing that we're finding out as a enterprise is we need to operate on large scales and all of the time. And that's becoming more and more critical as we join different countries, right? US, of course, is a behemoth for our company because we have the majority of our agents. But as we grow and expand into international areas, that changes things a little bit, in that we won't be expecting the same amount of load from the same amount of times anymore, and we should be anticipating load, like I said, 24/7. So our architecture, when it started, and I wasn't here, but I can imagine when it started, EXP broke down their monolith, which was enterprise. It did everything, and they broke that into pieces of the business, logical pieces of the business. I mean, transactions separate, an agent database separate, and then we went a little bit more granular. And with microservices, the idea is to break things up into services. I mean, small components, and you can really get as granular as you want. But there's a lot of benefit to doing that. One is that you're loosely coupling things, and I'll get into the benefits of that in a second. But you break down the business into bite-sized components, or hopefully they're bite-sized. But doing that, as you can imagine, is quite the undertaking. Like I said in the beginning, when I first heard of EXP was like 2 years ago at Mendix World, in which EXP's leaders were doing an igloo talk about how they've taken their monolith and created microservices out of it. Well, here we are a couple years later, and we're still in the process of doing that. Microservices is never, at least for us, has been ever evolving and ever changing, and it's always something that we're working to strive towards, to architect our systems to be in line with. I think overall, just in general, at least for me, it's easy to during a normal development cycle, as you get requests from the business to add new features or whatever, it's easy to say, oh, okay, I'll just add this onto this microservices. So what we began to see was we broke out enterprise into chunks, right, into microservices. But those microservices then started to become little monoliths of their own. And so when developing a microservices architecture and trying to maintain that, it takes discipline. And it takes, when you receive requests for new features, it takes discipline to take a step back and get everyone on the same page and to say, hey, look, is this something that we need to add to a current service, or does this deserve to be a service on its own? And so the benefits of having things that are loosely coupled, there's a lot. And one of those is being, I think, just a low curve of understanding. And when you have things that are in small components, it's much easier to diagnose, problems with small pieces. It's much easier to understand. So when you're onboarding new developers, it doesn't take as long for them to get up to speed with a microservice if it's small enough, as opposed to, trying to teach them something of a monolith or something that's a lot bigger. Also, it spreads out when you decouple things, it spreads out the risk. When you have each service, when you have little, like a specific thing, parts of logic that one app is just devoted to, then it can easier scale because the app has its own set of allocated resources, and it's not affected by anything else that might be sharing those resources because it's only for itself. I think one thing that I've seen a couple times is an app may get hung up as a result of another part of the app that didn't really, if it wasn't broken up into microservices and everything was just operating in one application, you're opening yourself up to risk in that, okay, if one area of the application, throws an infinite loop, okay, the whole app is dead. Well, take that, into a true microservices architecture, when everything is its own application. If one piece dies, you build security around that. You have defensive measures if that one piece dies, and also your other components now are not as affected by that an outage as it would have been before. And so when you're thinking about breaking things up into microservices as well, I think it's easy to think in terms of, like, okay, like I said, like a piece of logic, like, okay, this application needs to just process and hold transactions. There's an application that may be sources of truth for certain types of data. Like I just said, there's an application that's a source of truth for a transaction. There's an application that's a source of truth for payment records, for agents. But there can be applications that don't necessarily need to be like that. There's other kind of types of applications. There could be ones that are basically middlemen. There could be applications that basically are just, they don't really have a database. They just kind of direct things. They're like brokers. All of those together are different types of applications in a microservices architecture. Another thing is traditionally, when you break apart your business into microservices, one thing that you will be thinking about is your database. Inherently in every Mendex application that you create, you have, of course, you can make your logic and then you can have your database with it. Ideally, you want to separate that database layer. And that's something that at EXP, we're still exploring and always rethinking on how to do. Because you wouldn't want to duplicate your database multiple times and maintain that across multiple locations. You would want to have it so there is either one source of truth for certain data sets, but that's not always, or at least when EXP started down this path, not always the most, it doesn't always, I think, work. And so sometimes we've had to duplicate databases because it's more efficient to retrieve the data when we need it, as opposed to going to a source of truth. Of course, that's changing. Now we use a couple of different methods to access our databases. We have something like a data warehouse or data lake. We send our data to, it consumes all the data, and we're beginning to use that to query data when we need it. but that gets into the communication part of these services. And that's where Kafka comes in. Of course, there's many different methods for communicating data. But for us, for EXP in large, we have utilized Kafka heavily to pass data between our services. And there's some good reasons for that. And why that works for us is for a couple things. A lot of our data kind of waterfalls down and doesn't necessarily need or rely on there being a response from the consumer of that data. I think every situation is unique, and for anyone else implementing this, you may not use Kafka or may prefer to use APIs, which is fine. We also use APIs for servicing data as well, but for us, like I said, because the majority of our data waterfalls down in that, an agent may process a transaction, that transaction is processed, but then that data needs to be worked with. That data then goes down the line. Another service deals with that, adds upon it or creates it into something else. And then that data then needs to be paid, and new data sets are made from that. And so it keeps on going down in steps. And what Kafka provides is a way to publish data and for any one of our services to then consume it. And it does so in a cool way in that, we don't have to necessarily also worry about things like downtime of certain services, because those Kafka messages that are published on a topic don't just go away. They'll stay there. And so, for example, if I have downtime on one of my services, say it's down for like a day or more for some odd reason, which never happens with us. And the app is brought back up, well, great. It just picks up where it left off. Within the Kafka cluster, the messages are still sitting there waiting for us to consume it. That's a benefit. Also, we don't you don't really have you don't really have, there's no errors in the API, right? You're just consuming what they produce. So that's how we use Kafka. Just to touch on this, on our producer and consumer philosophy, I think what we've adopted for the most part is that our producers will produce as much data as they think is needed, generally more than they think is needed. And it's left up to the consumers of that data to consume or ignore what they care about. That's just the way that we operate. That works for us. Yeah, so that gets into what I've just been talking about, since I forgot to click. Again, they're loosely coupled. Small applications, they're easier to manage, easier to scale. They have their own set of allocated resources. Small can be managed by small teams, smaller learning curve. And our data flow goes downstream. And so I think now I could keep talking for longer, but I'll hand it off to Lennert to really get into the nitty-gritty of how Kafka operates.
Thanks, Jon. Was a great story.
Thank you. Appreciate it.
Well done. All right. Take it over. See if this works. Should work. Something like this. Yeah, works. See, Jeroen nodding.
That was way too smooth. Way too smooth.
Oh, okay. Great. Good stuff. Okay, so let's get into this Kafka piece. So first question would be, what exactly is Kafka, right? So when you look up the exact definition of what kind of system Apache Kafka is, it will tell you that Apache Kafka is a event streaming service, right? And if you're like me, you'll be like, sounds cool, but what is it exactly? What does that mean? So when we look at a regular application, we will have a database, right? As you see in this picture. And this database encourages us to think in objects, right? It likes us to think in EXP's example of agents, of properties, real estate, or transactions. But for Kafka, that is slightly different, right? Kafka doesn't like to think in objects. Kafka likes to think in events, right? So say we zoom in on this agent, right? Instead of thinking about an agent, Kafka likes to think in the events that an agent can undertake, right? So we can, for example, have a new user, a new agent, or we can have an agent edits his own details, or we can even delete an agent, right? And what Kafka does, it stores all these events as a sequence, right? A log of events. And it does this on a time basis, right? So the oldest one will be at the beginning and the newest ones will be at the end. And it will name all these events, and the collection of all these events, this log, is in Kafka language refers to as a topic, which John also already mentioned, right? So yeah, that's where Kafka is distinctly different from a normal database, right? So how does Kafka handle all these events? So it all starts with a producer, right? The producer is the piece of software that Kafka uses to send their messages to their Kafka cluster, where they are then stored, right? We can have one, we can have multiple producers. These producers can live on the same application or different applications. So these 3 producers can belong to, for example, 3 different applications or microservices in the case of EXP. So how does it get this stuff over? So when we try to send an event to a Kafka cluster, we do this in the form of a record. And a record is simply a combination of a topic name and the original message that you'd like to send. And this will just be a string value, right? Just an unlimited string where you can put anything you like in. So then we send this to a certain topic that lives on the Kafka cluster. And the Kafka cluster will store this as this log of events that we saw on the previous slide. And then when we move over to the receiving end, we will have consumers, right? So these consumers will take the information, take these records from the Kafka clusters and bring it over to our other applications that are interested. So you don't need to consume all the topics. You can only consume the topics that a certain application is interested in. So for example, the record that we just sent with the producer on the top left, that is interesting for the third consumer, right? Because that one is subscribed to topic B in this case. So let's get this to a use case to give it a bit more context. So say we have this microservice, right? Just an example. We have a microservice that is responsible for the agent management, right? So this microservice will store all the agent details, for example. So there is an event, right? Some agent decided to change his email for whatever reason. What do? So we create this record that belongs to a topic named agent edit, right? And we use the producer to send that information over to our Kafka cluster. And in this message, we have this unlimited string that I mentioned before. And we decided to put a JSON structure in there, right? We have this object represent as a JSON structure that is then living on the Kafka cluster from that point on. So that's great. Now we got our message on the Kafka cluster. Now we need to get it to our microservices. So say we have this nice group of microservices, right? So this is somewhat like EXP could have it. So we have the cluster on one side and we have the microservices on the other. So we have something with real estate, we have something with transactions, we have some stuff with billing, but the real estate microservice is probably not that interested in an agent changing their email address, right? So that one won't consume that data. But billing might be, because maybe when somebody gets his paycheck, he wants it to receive that by email instead of in the regular mail, right? So that microservice will then create a consumer for that certain topic, right? So in this case, that was the user edit topic, and we'll have a consumer pull the data from the Kafka cluster, so he can then consume it and save whatever he needs from it. So how do we use Apache Kafka with Mendix at EXP, right? So at EXP, the first step when we want to send data over to the Kafka cluster is we create a object called a message in the original Mendix database, right? This message is, among other things, a collection of the topic name, the value, which is the JSON structure, and the status. And the status in this case will be to be sent, because when we create this message, it is still living in our database and it hasn't been sent to the actual Kafka cluster, right? So how do we get this over? We have a thread running in the background, and that will be our producer, right, that we saw before. So here's a piece of pseudocode to represent how this producer works. So what it does, we start this loop on line 1, where we keep it running forever until we decide to stop it. Then on line 3, you see that we're trying to retrieve some messages. So what this function is doing is looking in the Mendex database for messages that are in the status to be sent, right? And it takes up to a certain batch size of messages each time. So then on line 6, we see that when we, or on line 4, sorry, let me go back. Let me do this in order. So when we on line 4, we see when there are messages, right? We jump into this if statement. And then on line 6, we convert these messages, these Mendex objects, to records, because Apache Kafka doesn't know our message object, so we need to put it in a record object, which is familiar for the Kafka software. So then we call a producer send, which takes the standard Kafka producer, which is already ready for you when you import the module. And then you simply say send, right? We take this batch, take these records that we created, and just push them to the Kafka cluster. And then as a final step, we need to take the messages that we just received and change the status, this enumeration value, to send. So when we look in the application, we will know that this group of messages have actually been sent to the Kafka cluster. So yeah, that is how we send messages at EXP. And then on the other side, we will have a consumer. Right. This is very similar. So again, for a consumer, we will also have this thread running in the background, and it looks similar, as I said. So this thread will also be running for as long as we want it to, right? So we start it up, say, all right, you are the consumer for this user edit topic, right? We start it up, and it will start looking on the cluster, or will ask the cluster every X milliseconds, are there any records that I'm interested in? Right, and that's what happens on line 3. It will say Kafka consumer poll, and it will retrieve all these records that belong to a certain topic that it hasn't consumed before. And Kafka will make sure that we always get each record once, not twice, once, but we will receive every single one of them. So then we create the original message object. This is the Mendix object that we started off with before the send. So we will have something to work with in our Mendex application, and we will process that using a queued action, right? And the process queue. So you break this down, this will look something like this. You start off with this record object in Java, which is a Kafka entity or object, I should say. Then we convert it to a message object, which is a simple Mendex entity. And then we create a queued action in Mendix, and this queued action will eventually be picked up by our process queue, right? And that will execute the microflow in the background. I'm sure most of you will be familiar with this this behavior. So how does this microflow then look like? Or what does it look like? So this is, I think, very familiar for most of you. So you have this queued action, and associated with queued action, you will have your object to work with, right? And so in this case, this will be our Kafka message. And the second step will be to take this JSON structure that was originally in this record and convert it back to a new or the same Mendex object. So then we'll have something to go on. Then we can process it. So that will be the sub update object microflow in this case. This is just an example, of course. So that this microflow could, for example, be for the user edit, right? So we get the message, we transfer the JSON or parse the JSON to a agent object, and then we process it by updating the email address within the agent entity. And as a last step, we will change the lifecycle status of the message object to process, because I forgot to mention that earlier, but when we have a new message that we create using the consumer, it will of course not be in the status to send, it will be in the status to be processed. So at the end of this microflow, we'll put it to processed. And yeah, that's how we consume messages at EXP. There's a lot more to it, but this is yeah, somewhat a high level overview of what's going on. So it's not done, right? We're still working on the Kafka module. So lately we've been working on the performance stability. So we create messages, right, for every message that we want to send to Kafka, and every message we receive, we will create this a new message entity. And when we are the producer thread that we've seen before, we'll look for messages in the database, right? So when this table gets really large, we saw that the retrieval times of the messages got very large as well, which is unfortunate because that will impact the performance. So we measured that with an empty database or just a few messages in there. It will do 350 messages a second. And when these databases got super large, like crazy large, we messaged the performance could drop to about 7 messages per second, which was not what we wanted at all, of course. So we did some database optimizations similar to what Mendex did for their task queue, which was we will have a object storing all the messages that still need to be worked on, right? And then we have an object that collects all these objects that have been processed. So we have 2 piles. One needs to be done, one already done. So we're only querying the stuff that still needs to be done, right? Which will generally be a small pile because we should be able to keep up with the work that is given to our producers and consumers. And we've even worked on a version without any database interaction. So we won't be storing any messages on the database, and we will be handing everything in memory and just passing it to Kafka directly. And we've measured performance of 1,000 times faster in similar circumstances. So we were about, at the bottom, we were at 7 messages. So this is now without any database interaction, we can go to 7,000, which is realistic when you look at, Kafka numbers. Kafka is a very fast platform when used correctly, and there's a lot more we can tweak. So we are still discovering all the possibilities of Kafka and how we can get the most out of this. So yeah, I think that was my part. I think that we are still on time for some questions.
Yeah. Thank you very much, both of you, because I think that the presentations combined give a very good idea on the architectural as a whole, and the individual components in per Mendex application. There are indeed a few questions, so a few in the chat and a few in the Q&A. I will drag them in front of me. So first one is from Dalibor. I see what module was used to connect Kafka with the Mendex app.
Yeah, I think a colleague built his own at the beginning, right? I came in once there was already a pretty solid foundation, and I worked from there. But from what I heard is that another colleague, Mitchell, built this basically from the ground up. There is some basic module that allows you that you can import for the Kafka module delivered by Apache. Correct me if I'm wrong, John, but that's what I've seen in the App Store. There is a standard module, and that should get you started, right? And we just added upon that for our own special implementation of Kafka.
Very well. I think there is another question in line with this one, but we will come to that later. It's about the implementation in the module itself.
Mm-hmm.
But thanks for this one. I do have one from Stefan in the chat. How do you deal with new consumers, so new applications? Does the new consumer receive all events from Kafka for the relevant topics, or do you have an alternative for such initial loads? So new applications is the question about.
Yeah, so you mean like there is already a lot of data on the Kafka cluster, and you create a new consumer on a blank application. That's what I understand from that, right? So you have this cluster that already been there for ages, and then you start a new consumer. So what you can do is you can say, I only want new data. I only want data that has been a week old. You can resend all the data, right, from the original application, because that still has all the most relevant data in its own database. So that's what John was talking about with the every app having its own truth, right? And then one application is the ground truth for a certain piece of data, so that can resend it. So yeah, there are multiple ways to run, but there is also a Kafka Connect we recently found, and that's able to quickly move all data from from the cluster to your application.
Very well. The next question is one from Joost. It's about the user experience of such a microservice architecture. So I think, John, that would be a question for you.
Sure.
So maybe you can see it already in the Q&A, but he's asking, suppose an agent or other users require data from multiple microservices, and how does EXP approaches such use cases? And then he's talking about like a gateway app, which you can use as a user interface on top of all the other microservices, or multiple browser windows. Maybe you can elaborate on that.
Yeah, we still experiment with this. Ideally, for user interaction in your app, if they're just requesting data, what I think where we're trending in regards to how our agents are serviced is we have that data pool layer, as we call it, the data warehouse or data lake. And so when the user needs info, then they hit that API and they get that. So generally, when we're going through just changing of data as a part of a normal data flow, we'll utilize Kafka. But then when the users need to see data, just view it, read it, we'll utilize that data warehouse, and they just hit the API and then get the numbers. If they need to, I mean, we have some instances where those users need to interact with the data. They need to change. They would kick something off, it would change it, set some new data. I think we've experimented with that with iframes and such.
Well, I think it's also very interesting to know how different companies are coping with that issue, and I think a data warehouse is especially one of them. So if I'm understanding you correctly, you're isolating like the process for a certain user group, and they're using that application, which is using data from several applications because they go through that data layer, and thereby
Right.
You don't need different applications or UIs or etc.
Yeah, and we use that data warehouse like for reporting purposes as well, because it can take that load. It's meant to take that load of serving up large data sets, and because we don't want to bog down our services with holding any data as much as possible, and we don't want people querying them either. That's how we've been. That's how we're trending towards.
Understandable. Very well. Then we do have another question from Xiwen in the. Hopefully, I'm pronouncing that correctly, but it's in the chat. It's about crashes. So, what if the producer itself crashes in between when sending messages to Kafka and updating the Mendex database? So, like the thing you don't want. The messages will be sent twice. Is that a problem for Kafka or the consumers?
Shall I take this one, John, or do you want to?
Yeah. No, yeah, I was just going to say it restarts, but you.
Yeah. So within Kafka, there is a default retry mechanism, right? So Kafka will retry up to, I don't know, 65,000 times when a message gets stuck in this loop, right? So you send it out, and as soon as Kafka connected to that message, so it is not necessarily already in the cluster, but it's on its way there, then it will retry up to how many times you would like, basically. And say it fails in the scenario of EXP, we always have this local message, right? We have this message in the database that we create before we start sending it. So say it fails, right? Then Kafka will, locally send back a failed message, like it didn't work for some reason, whatever. And then we'll get this back in Mendix, right? And then we'll simply set this message to fail to send the status. And we have a event that runs every X minutes to retry those messages that are in this state. So that will make sure that every message ends up on the cluster. And regarding your comment that a message can be there twice, Kafka is very strict on this, right? Kafka will only save one message per whatever needs to be there. It will always have one record, always. It makes very sure of that. You don't have to do anything. It's just standard Kafka stuff.
Those are the good things about using good stuff.
Yep. Yeah, it works really nicely.
Oh, very well. I do see that it's already 8 o'clock, at least at Central European summertime. So that will be the end of this this meetup for now. There are a few other good questions waiting to be answered in the Q&A. Two were from Joost, who already left us for the production deployment, which was waiting for him. So I think it's a good moment to thank you all for joining, and especially Jon and Lennert. Thank you for sharing your insights in the EXP landscape and the implementations around Apache Kafka. I think especially I spoke with Lennert before, but it does stay something that's several companies or several clients or several Mendex practices are looking for implementing microservices in their own landscape, but like thinking about it and doing it are two completely different things. So I think it's very interesting to learn from you there. Sure. So then again, I think Lennert, you can skip to the last slide. So
oh yeah, sorry.
We can have a nappy time.
Look at that.
Very well. So thanks again, everyone. Hopefully you enjoyed your evening, and we will have a chance to gather you all in a physical manner sooner than later. So for now, have a good evening, have a good afternoon, have a good day, and speak soon.
Right.
Bye-bye.
Bye, everyone.
Bye-bye.